If you go into this just thinking about technology, you're not going to hit it. There's this whole other human element, which is what the technology actually is helping. And every person is a little bit different, but they have these kind of overlying similarities. It's actually being able to stand up on your own and hug someone, being able to feed yourself. It's part of the person at that point. I was a kid that took apart everything I got when I was little. I was always curious about how things work. In the 8th grade, my science fair project was an animatronic robotic hand.
Surprisingly, this does have a good amount of strength.
The fingers were electrical tubing, fishing line is the tendons, simple little servo motors from RC airplanes. After I made the first prototype, I entered that into the science fair. People wanted to see it move, people wanted to see it work, they wanted to touch it, they wanted to feel it. It was something that they could relate to. After that science fair, I went back to the drawing board and I saw 100 different ways I could make it better. I could add an opposable thumb, I could add individual finger joints.
And now let's try picking something up.
I went through the whole science fair process again, right? But I noticed a small girl come up and she was spreading the fingers, she was looking at how every little thing worked, and she was so focused on some of the small details that no other kid would even think about looking at. And I realized that she was missing her right arm. It turns out that she was actually 7 years old. She had a very, very simple prosthetic. It was from the elbow to the fingertip, had one motion, open, close. It was kind of like a human-like claw. When I was talking to her parents, it turns out the whole process of the actual prosthetic cost through the insurance companies, through the actual fitting process and tweaking, cost about $80,000.
My main goal for the arm was to make it under $1,000, and I achieved that goal.
It changed everything I was doing. It changed my whole thought process from that moment on for the rest of my life. So I was featured in Popular Science magazine, and they covered the first full robotic arm I built. So it was the 3D printed hand, and then the windshield wiper motor for the elbow, and then kind of pieced together aluminum bits. And someone on the Robonaut team at Johnson Space Center at NASA saw this article and reached out to me and pretty much asked what I was doing over the summer. And if NASA calls you, asks you what you're doing over the summer, you're not doing anything over the summer. When I got there, the reality was you had 3 people watching over your shoulder that recorded every little bolt that you loosen. I would literally go home from NASA and work on my projects, well into the night, and then I felt like I was helping someone else's dream come true. With all these things happening, it gave me the perspective where, if I want to do what I like, and I'm very lucky that I know what I like, I need to go out and do it on my own. My goal is to not have a lot of money within this, it's to get this technology to people who need it. So I'm going to design each individual piece of the finger, and I'm going to start off with a basic sketch that then I'm going to build from. Then right from here, I would actually save this as a file that the 3D printer can just print for 20-30 minutes later, then have each joint, and then I would assemble that and see if this design works. If it doesn't, I would repeat this process until it does. If it does work, then I start assembling the rest of the hand, printing the rest of the fingers, putting everything together, adding the actuators, the electronics, and making the full hand. About 6 months ago, I was approached by a nonprofit in Florida. They said that they've been working with a small girl named Momo. She's about 9 years old. She's missing her right arm from her elbow to her fingertip, and she's been struggling to find prosthetics that actually work for her. It's so hard for a kid to have a prosthetic. 3D scanning is an obvious way to be able to make this better. If you can scan someone's residual limb and then be able to replicate a negative from that, you can then expedite this process tremendously. You can take a new scan, update things. It's a scalable solution at that point. Imagine the small girl that receives this prosthetic. How is that going to change her life? How is that going to change her parents' life? Everything has been building up to those points, and we are so close to being able to do it for 1 person, then 2 people, then 100 people. We're so close. We're right there.
How many years do you have in this?
At least 6 years.
The end result of this was just taking care of one of the work.
100%.